So imagine a world where machines alert you before they fail, maintenance is perfectly timed, and every action boosts uptime and profitability. This is the power of AI-driven TPM. So we'll talk about three of the topics today that we're going to talk about that are part of the 8 pillars of TPM: enhanced predictive maintenance, optimization of maintenance schedules, and data-driven continuous improvement. And we'll have an exciting demo a little bit later in the presentation. So the standard TPM has 8 pillars: health and safety in the environment, training and education, early management, focused improvements, administrative TPM, quality, planned maintenance, and autonomous maintenance. The interesting thing about autonomous maintenance is it doesn't mean robots roaming around vacuuming up the floor. It means that individual staff in plants in different operating environments can handle corrective and preventive actions on their own. They don't need management to come and tell them to run the checklist and other sorts of things. But it also is going to take on a new meaning as AI starts to mature, and we're going to talk about that. So what's the problem? Well, there are quite a few problems in traditional manufacturing: lots of manual activities, excess scrap, reactive operations, and a big one is running to failure. Running the machine until it starts to break and pop screws and things like that, and it creates a mess. Now, these problems increase costs. It's been estimated up to 40% of waste is due to these challenges in traditional TPM. So today we're going to focus on the manual issues of data entry and disjointed data collection, running to failure, which means you have unpredictable breakdowns, which leads to unpredictable downtime, which leads to orders not being fulfilled, available to promised dates moving out, etc. And lastly, reactive operations, which means you have limited visibility into the real-time performance of your machines, of your process, of your lines, of your factory. So don't let downtime dictate your operations. Unlock the power of AI-driven TPM. So what solutions, especially in the predictive maintenance area, are there? Well, there are 2, and they're weak. There is the mathematical one was sort of first, where you had fixed threshold statistical rules where people watched machines over decades, and they said, okay, well, when you see this particular parameter exceed this, then it would trigger some activity. But that was a fixed number. Maybe you adjusted it over time, but you had a lot of spurious events from that. And traditional math models that you see on the bottom right, they had late alerts, high false positives. You had to constantly manually retune it, and there was often a single sensor focus. So if you had multiple operating parameters for a machine, it was very hard to do all that data collection manually and keep it up to date and do all your root mean squared and all those sorts of things to keep it going. So AI has a very positive improvement over those. Early and accurate alerts, self-learning adaptation, and multi-source fusion. Similarly, in the machine learning neural network area, it was better than the fixed threshold math models, but there was a high refresh cost. You had limited accuracy, and you're over-servicing, meaning you had a much larger, more sophisticated team of data scientists and data engineers putting this infrastructure together, but they still had to spend a lot of time hand-tuning the models because the environment was such that humans were developing how the models learned. So we'll talk about how that is improved with AI. So, which leads us to improving TPM. So how can AI help? Well, we remind ourselves that TPM's goal is to minimize downtime and maximize equipment uptime. So AI in digital's goal is, well, you want to start digitally processing information. You type once and it's available everywhere. You don't keep typing into a spreadsheet and copying it into SharePoint. Also, you want AI to help you predict failures and optimize maintenance schedules. So let's talk about, attacking this muda gap, this 40% of waste. So the first step is to digitize. Renew your TPM transformation with many digital applications that are used in place of electronic paper, meaning PowerPoints and Word documents, Excel files, whether they're in Google Sheets or in the cloud, you're still copying and pasting electronic paper into electronic file folders and trying to share them and aggregate them into larger and larger spreadsheets. And a colleague of mine out there calls them dumb sheets, if you understand that metaphor. So we want to improve that by having electronic versions of all of our practices in Lean, of production applications that tend to end up in spreadsheets, of quality applications that are point solutions here and there from multiple different companies, supply applications that are also the ERP system has 60 or 70% of the applications, but a lot of scheduling and inventory management, and my favorite metric called case fill rate is not available all the time in all these different platforms. And so if you digitize the practices that we have been using electronic paper for, you're attacking the first step to attacking TPM's MUDA. So what are the opportunities in AI across the whole pillar though? So these are just a sample, the ones that are highlighted across the different 8 pillars, but there are obviously more. So I'll just scamper through them pretty quickly. So in health and safety in the environment, you have AI versions of the Gemba walk, and training and education, you have AI-based training. In early management, you have AI-driven automatic alerts. That's what we're going to show you a little bit later. Automatic non-conformance reporting. You have a digital version of the 5 Whys and 6 Sigma, and how AI helps is once you start putting in the foundation information, the header information, you walked around the plant and you found some problems, AI in applications that are context sensitive will help generate some of the next steps that are occurring. So you put in the first why, then the AI will generate the next 4 whys, and it will start producing a project plan if you wanted to. Focused improvements, AI-driven action plans, because it can look at the context of all the activities that are going on across TPM, across maintenance, and produce a daily summary in a written paragraph to you all the time. We'll show you what that looks like. Administrative TPM, quality maintenance, planned maintenance, and then lastly, AI-assisted autonomous maintenance to help you with corrective and preventative actions. So while we're going through, if you have any questions, please post them in the chat. So as you see, there are many ways to improve TPM. Today, we're going to talk about how to unlock some high ROI improvements with these particular power plays. Enhanced predictive maintenance, then leading to optimization of maintenance schedules, and then data-driven continuous improvement. So let's demo the first one. So how do we move from reactive to proactive? We want to harness AI-enhanced TPM to maximize uptime. So we're going to have a system that has already learned how to watch a particular recirculating pump. The predictive cloud has already understood the vibratory patterns of this particular motor, and we're going to throw a wrench into the cloud that is a simulation of something going wrong with the motor. So the system is a real predictive maintenance cloud, and it's going to get a spurious event, which is simulating something happening in the motor, such as one of the bearings may be having an issue, oil is too low, things like that. So I'm going to change my screen for a second so you can see in real time what happens. So we have our monitoring small OEE screen over here. These are the feeds into an event table. Normally this would be hidden from you, it would be in memory. And so right now we have everything operating fine. The pump is pumping 150 liters a minute. We've been watching multiple pieces of equipment, and we have this little pump down. Well, it's a pretty big pump. and it's going to have an anomaly, and we're going to trigger this screen over here, but it's all going to happen without me touching the screen. So now we're going to trigger the anomaly. This is going to happen in real time, and have a look at the left side of the screen. So we're simulating a maximum G-force. The value is 417. You see it being picked up over here. It now popped this screen. This is what, and you also heard the little ding in the background. You may not have heard that. There was an email sent at the same time to me, and if I had clicked on it, I would be taken to the screen here. So what is interesting about this screen is that we have the digital context of what the problem was. That's here. The event date, the measurement, the unit of measure, what the item, what the equipment, what the asset number was. We have, because of this information, and the environment will put the right information into an email panel, so you can email the shift manager, whoever is appropriate. We will find and search through the standard operating procedures, those procedures that are important to this particular item. You're allowed to put any notes here. There may be some additional files that you may need to look at, and then you can generate a work order. You can generate a non-conformance report, or whatever the process is in your company. Okay, so from that, what might happen? Well, we might be able to pull up a manager or a lead, maybe pulling up a maintenance screen. And this is what digitization would look like, where, well, maybe we actually put what happened over here on a project list. Now predictive, it hasn't failed yet, it's still operating perfectly, but now we can schedule ahead of time a review of what's happening with this particular machine. In the last 24 hours, the AI can look through the events that have happened, other information that may be available to it, and it'll produce a summary over here autonomously. You don't have to write it yourself. You can add to it if you want. There are options in configuration to allow you to email this to an email group list if you want. If you do have some downtimes, they'll appear here in a summary. There are root causes that you may be tracking based on what's happening. In this case, there was a bearing system degradation, and tracking your projects, your maintenance, as a set of projects, allows you to manage it like a Microsoft project plan. This has a Gantt chart capability and table capability, just like Microsoft Project, but you're not paying $400 or $500 a license for everybody to see that. This happens to be a list of my tasks, and they are pulled from multiple projects all over. So I don't have to really worry about other people's projects and looking through lots and lots of tasks to find my tasks. I can just deal with just my tasks alone. So at Praxis, we call this overall process, this digitization process, AAA process. Access, analysis, and action, and it's obviously in a continuous basis, so you're continually accessing information across the 8 pillars. You're continually analyzing it. AI is helping you do that in real time, all the time, 24 hours a day, 7 days a week. And continuous action, which allows you to access and implement and process practices and processes to help you run your organization. So before we take questions, thank you for joining. Some takeaways: AI enhanced TPM shifts firefighting to proactive uptime to help you predict failures. And then, because you can predict your failure, you can optimize your schedule. You can schedule things when you have the resources and the equipment available to you, instead of running like a fire person all the time with emergencies. Praxis helps digitize the whole process through applications, capturing real-time data, and serving up instant predictive insights. We think the high ROI power plays are enhanced predictive maintenance, again, the optimization of schedules and data-driven continuous improvements. So next steps are, come and book your personalized demo or pilot a quick win, and after that you can scale and optimize. Well, thank you very much, and look forward to any questions that you might have.
There's a question in the chat. How do you use AI?
So so as Praxi, it is part of our infrastructure. It is optional in the sense that our application, we have two versions of applications if you need that. A non-AI version for those who are not finished with their AI maturity model or AI strategy. For those that are embarking on the AI process in the future, we can have applications that have AI imbued in it. And there's lots of ways to utilize AI. We use them to help speed up a process. So you put information like in the Gemba walk, and it will devise the action item list for you from what you've walked around and typed in, including all the pictures and what the pictures show. And then it will help you create a project plan within our tooling. There are much more advanced versions of what we do with AI, and I enjoin you to come in and contact us and get a demo.
There's another question in the chat. Does the system work with MES, ERP, or other third-party solutions?
Yes, we have plenty of diagrams that will show you how we integrate to SAP and Oracle and JD Edwards and Odoo and other things, but technically, simply, they all have standardized on REST APIs and SQL API calls. So we have no problem integrating to those things.
Any other questions?
One more comment about that. We're actually a build partner with SAP, and we have some ex-SAP people in the company. So we're very familiar with all the different types of manufacturing systems that SAP is one of the purveyors of. So ERP and warehouse management and PLM and PDM and quality and order management, etc.
Looks like that's it.
Okay, well, thank you all for joining today. The video will be also available on our website. We also have a white paper on this particular topic, and we will be emailing that to everyone when we are complete with our presentation today.